if we had every water heater in the Boston Metro, like the MSA, as an intelligent grid connected water heater, you would have almost as much capacity that you could shift around as a nuclear scale power plant without building a nuclear scale power plant. And so there's so many next order effects to having intelligent appliances that have like built-in storage, and like a water heater is honestly like the holy grail of this kind of stuff, because a tank of water with intelligence, it's effectively a battery because you're storing heat inside it.
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I'm here with Luke Winston-Almanzar, the CEO and co-founder of Reservoir. Luke and his team are reducing the energy demand and emissions associated with residential water heating, which is around 20% of a typical home's energy use. Their water heater uses a heat pump and industrial controls and some smart software to make this happen, which I'm hoping to get into the details of. As far as I can tell, it's about both energy efficient heating and shifting that energy use to times of the day when electricity is cleaner and cheaper, and then storing that in the form of hot water to be used when you need it. So you can think of it like a battery, which is pretty cool. It also looks like something I'd love to have in my home. I would recommend everyone check it out, the Reservoir Home website. And they've been really thoughtful about the features to improve user experience as well. So it's a really cool product. Prior to founding Reservoir in 2024, Luke spent over a decade at Form Labs, a leader in 3D printing. So he's no stranger to building and scaling hardware companies. Luke, it's awesome to have you on the show. Thanks for joining.
Yeah, it's great to be here. Thanks for having me, Dylan.
So I'm curious to hear a little more about your path to founding a climate-focused company. I see some, prior to Form Labs, just scrolling through your LinkedIn, I see some sustainability-focused roles early on in your career. I also see a bit of variety, like you founded a nonprofit to support underprivileged Chilean children. I'm curious, what has been driving you in your career, and is there a common thread that kind of ties it all together through to Reservoir?
It's a great question. I guess there's a couple of things. One, I'm very mission driven, as you can probably tell through that background. I also have a technical background, so I like doing things that have to do with technology. And I do like bringing it all together. I guess I've always wanted to solve like really, really big problems. And I think the climate and energy in particular are really interesting problems to address. So I guess after founding that nonprofit that you brought up, I ended up deciding to focus my graduate studies on energy business and climate policy. So I did a joint degree at Kennedy School of Government, as well as Harvard Business School, focused on energy business. And the goal was to get into the climate space, the energy space. And so I ended up jumping into a tiny company you've probably never heard of, called Siemens. And so they have a big clean tech portfolio. But I've kind of just always had an entrepreneurial gene in me. Particularly, it comes from my mom's side. A bunch of entrepreneurs in the family. And ended up meeting some guys, starting Form Labs, 3D printing company of all things, while I was at Siemens. I said, this sounds like really, really cool. And so I did a completely left turn. So it definitely satisfied the technical itch, the science itch, building a business, entrepreneur itch. I ended up spending about a decade there. So I was I joined on the founding team. I think I was the seventh person on the team. And I was the first generic like token MBA that did everything the engineers didn't want to do. And so that was like HR, that was like finance, that was operations, helped set up our first manufacturing line, but eventually helped build out like a lot of the go-to-market, ended up building sales teams, services teams. We worked across the globe. But basically, I spent a decade there, and we built a pretty big smart device company. So like if you think about a smart device, 3D printer is a smart device, right? And so Form Labs disrupted the space with a desktop 3D printer that gave way more people access to really, really powerful technology. After about a decade, I started getting that itch to get it back into the climate and energy space. And started an area I was very, very excited about was the built environment. And so, having helped build Form Labs, I asked myself a couple questions. Is like, one, how do I make an impact on many, 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 many homes? I had renovated a couple homes myself in Massachusetts. It took years, and my goal has always been to make a very, very big impact. So I was asking a question like, how do I get to as many homes as fast as possible? So it wasn't going to be by renovating them myself. The second question was, how do I build a business around it? And how do I do something with smart technology? Um, Ultimately, I came to water heating for a variety of reasons. So like, I guess there's when you start a company, there's the side that's like logical. A lot of people call it first principles, and then there's the side that's the personal side of things. And so on the first principle side of things, I guess one of the biggest reasons I started Reservoir is because I realized I did like some of the math in my own house, and I realized I was using more energy to heat my water than to drive my electric car. Um, and yeah, yeah. So this is something that most people don't really realize. So like you can have like a 50-gallon electric resistance water heater that uses between like 3 and 5 megawatt hours. You can drive a Tesla Model Y or an Ionic 5 10,000 miles and it's 2.8 megawatt hours a year, right? And so maybe you're using more power instantaneously with an electric car, but like over the course of a year, I guess the way I put it is hot water is probably the biggest energy guzzler in our lives that nobody's talking about. And so from a first principles perspective, I was asking myself like, okay, how do I impact homes fast? And I was trying to honestly just enumerate which are the big uses of energy. Where can I make an impact? And so like I went down the list and I was like, okay, space heating, obviously, air conditioning, and then water heating didn't even enter my mind. And then I went down to like cooking, like refrigeration, all these kinds of things that come to the mind first. And then when I found out that water heating was number two, it just blew my mind. And I was like, okay, this is interesting. And so what I also realized was the typical water heater, even though it uses this much energy, it's like it's flying blind, right? Like the typical water heater is less intelligent than the typical air fryer. And yet, we have so much technology available to us, and you have something that's using this god awful amount of energy, and yet it's flying blind. And so then I was like, aha, okay, there's a chance to add some innovation to it. Um, but then we started having the idea of like, what else can we actually add to it? And I can go into some more of those kinds of details. So that's like the first principle side. There's an impact to make. On the personal side of things, it's um, you know, I grew up in rural New Mexico. I'm the middle of five boys, and we had a 50-gallon gas tank water heater, and I can't tell you how many cold showers I had. Like like we would fight over cold showers. Like we would fight over who gets to get the first shower and stuff like that. And so, like honestly, since I was a kid, I just love long hot showers. At the same time, my mom was single. She had five kids, and she was the kind of mom that's like running around the house saying like, "Close the doors! You're letting the heat out,
Oh
or turn
yeah,
off the lights." All these kinds of
same.
things. And so,
Yeah,
yeah, yeah. So I'm sure there's a lot of people on the
totally.
on the pod like
That's my
who,
mom. Yeah.
yeah. And so for me, it's always been I want to start a climate company that brings like more comfort, like more joy, but also it's accessible, right? Like and a single mother who's like worried about energy bills can still get it and actually improve the comfort of her family, but also save money, right?
That kind of blows my mind how much energy it is. I'm like relative to a EV. That's crazy. Um, when you were looking at this, and this was just a couple of years ago, what is, I guess one thing you look at is, there's kind of the conventional gas tank water heaters or electric, like resistive heated tank water heaters. We also have heat pump water heaters. I'm curious, like when you looked at sort of what's already on the market, did you feel like there's a lot of headroom to make improvement beyond even what was best in class at that time a couple of years ago? Or is it more about convincing people to adopt like heat pump technology and that kind of thing?
Yeah, yeah. So I mean, if you look at the market, by far and large, the most water heaters are an electric resistance tank or a gas tank. And then you have a variety of others, like you have tankless gas and you have other things like that. And then a small sliver is heat pump water heaters. And I guess the opportunity we saw was, I guess when I started looking at heat pump water heaters, I was like, I started looking at them thinking like, okay, this is a very, very efficient choice. But me as a homeowner, like I had a tankless gas and I didn't want one. Like I was like, my wife is going to be mad at me because we're going to run out of hot water or something like that. Because the great thing about a heat pump is it's super efficient. The problem with it is it's slow. And so if you take a typical heat pump water heater, that heat pump will be like 4 times the efficiency of the alternative, but it would also take like 5 to 6 hours to heat up that tank, right? And so if you're using a system with a reactive kind of algorithm, like I drew water, so I'm going to start heating up, it just can't heat up. And so one, you need some more intelligence behind it, but then you can also add a bunch more stuff to it. I guess like my philosophy, honestly, and I guess this is coming from having had my trip through a decade in 3D printing and other places, is I think better products get adopted more. It's like it's kind of like obvious, right? But like we take lessons from going back to electric vehicles. Like we take lessons, like people didn't get excited about electric vehicles because they're electric, right? They got excited about them because they're better cars. Like they go from 0 to 60 in 3.5 seconds. And so my question was, how do we do the same with water heating? And honestly, I have a lot of friends who care about the environment. I have a lot of friends who would love to be more efficient, but they don't want to run out of hot water. you know, they want other systems in it like that. They don't want to deal with too many headaches with different things like that. And so if push comes to shove, people are going to choose hot water over efficiency. And there's definitely people who will choose the efficiency. But if we're trying to think about how to get to every home in America, we wanted to do something that has the efficiency of a heat pump water heater, but has like the comfort level of a tankless gas system. And that's ultimately what we're talking about. But then it's also affordable and as easy to get as an oil change, right?
Yeah, that was kind of my guess going into this, is that it's about, yes, it's a more efficient technology than kind of what most people have, but it's really, a lot of this is about how do you get people to want that technology, and how do you make that whole experience better um, than what's currently kind of standard. Yeah.
Yeah, I don't care how efficient the product is. If it's less than 2% of the market, it's not making a big difference,
Yeah.
right? And
Right. You
so,
need
like,
adoption. Yeah.
you need adoption. Like the technologies that, I mean, like heat pump water heater. So we have a heat pump in our system. So like Reservoir integrates a heat pump, multiple other heating elements, also a computer and a bunch of other stuff we can get into. But like heat pump water heaters are not a new thing. They were invented in the 40s, right? Like the first heat pump water heater was invented in the 40s. There's been multiple waves of heat pump water heaters and everything like that. And so um, I guess that somewhat is kind of going to similar kind of trends as you might see with electric vehicles. The first couple waves of electric vehicles were not successful either, right? And then you start getting better products.
Yeah. So let's get into that. So you just kind of laid out the pros and cons of of like typical heat pump water heaters, super efficient, but the user experience is not great because of how long it takes to heat. What are you doing differently to improve that?
Yeah, so we're doing a couple things. So, like I said, we have an integrated heat pump water heater, but we add predictive computer on it, as well as some industrial controls. So we're not just adding intelligence for intelligence sake. We're adding intelligence so that we can actually add capability. So, for one, Reservoir spends the first month in your house learning your behavior, and so it starts learning when Dylan showers. So at the most basic level, what that lets it do is heat when you need it and not heat when you don't need it. What it also allows you to do is preemptively heat using the heat pump more than where you just have a reactive algorithm, right? So as I was mentioning, like the heat pump takes 5 to 6 hours to heat up the tank, but you can get anywhere on time by walking if you leave on time. And so if we know on average when you shower, if Dylan showers at 6 in the morning every morning, we start heating at 1 in the morning. So that's like the most basic side of things. But then we add a couple extra capabilities. So I guess the way we put it is Reservoir can protect your house, it can raise your comfort, and it can save you a bunch of money. And so when I say it can raise your comfort, like one of the things it can do is it can get 150 gallons out of a 50-gallon tank. And we actually have a mode called party mode. And so we actually have more flex capacity than any other system on the market. And one of the ways we do that, we're not the only ones on the market that add like a mixing valve to a tank so that you can superheat the water, and then cold mix it down. But we actually have multiple heating elements, which we can use in a very efficient, dynamic way. So we can actually get that extra gear that basically nobody else on the market has. We also have a built-in recirculation pump. And so we can use that predictive algorithm. So since we know when on average you shower, we can anticipate when you're going to get in the shower. And then we could use our built-in recirculation pump to preheat your pipes before you even open your faucet. And then we give you something that we call the no wait shower. It's instant hot water. The great thing about that is you don't have to spend that 2 minutes shivering, depending on where you are. You can save thousands of gallons of water a year, and it's just nice. But because it's predictive, it's not wasting a ton of energy. Like a typical recirculation pump might be just like warming your pipes and warming your pipes. Um, the the way we actually use that same technology, like I said, there's intelligence plus capability. The way we use that same technology to protect your house is we can actually sample your cold water. We can predict if that water is on the verge of freezing, and then we could say, "Hey, Dylan, do you want us to pump warm water into your pipes so they don't freeze?" And usually the answer is yes. so, um, so we have kind of like this unique system that's able to interact with your plumbing and monitor your plumbing in a way that no other system can. So we have like a pressure sensor, we have an ultrasonic flow meter, and we've been able to spot leaks in our customers' homes that had nothing to do with the reservoir and actually proactively warn them, and say like, "Hey, John Doe, your pipes are leaking. You should get that checked, or your pressure is too high. You should install a pressure reducing valve." And so that's where we just started asking the question of how do you get more out of your water heater, right? Like it's this big device. It's like the most important, expensive device in your plumbing system, and it can do so much more work. And you add intelligence and some industrial controls, and you can do that.
Yeah. How do you do leak detection? Are you actually kind of being smart about how flow looks differently when somebody has a faucet on than when there's sort of a constant leak, or how do you tell the difference?
Yeah, so there's a couple different places where you can spot a leak. Like one is on the water heater itself. Like you can sense it in like the drain pan, and that's relatively typical. And then you can also have auto leak shut off, which we actually have built into our system. And so we can actually automatically shut off the system. You can even do it on your phone, if you want to play a joke on your wife. Don't do that.
I do.
But you want to do it on your when your kids are teenagers. That's what you want to do. Um, so, but then there's leaks in the system itself that you can detect, and actually some insurance companies actually provide discounts for having that kind of technology. But then what we can sense is we can sense leaks in your hot plumbing lines, and so that's a mix of flow sensing as well as pressure sensing. And so we've been able to, we like I said, we one customer we told them you have a gallon per hour leak in your house, and we asked him, did something happen to your plumbing system previously? And he said, well, yeah, oh, actually, a year and a half ago, my pipes had frozen. I just didn't think it was that damaging.
Um, and the multiple heating elements. So you have a heat pump, and then are you also doing resistive heating when you need kind of faster heating? Is that what's going on?
Yeah, yeah. So for people not quite as familiar with like heat pump water heaters, the typical one has like a heat pump, a tank, and then two electric resistance elements inside the tank, and so those try to heat like 50 gallons at once. We actually added a third electric resistance element, so we actually have an inline booster heater. And so you wouldn't be able to tell if you look at the system. Like if my co-founder Gabe, he actually worked at Apple, and so he did such a good job on the industrial design. If you look at it, you're like, okay, that's just a water heater. There's a lot actually going on in the system. And so what that booster heater allows us to do is instead of trying to heat the entire tank of water, we can heat the marginal amount of water, so like milliliters at a time. And so if you, Dylan, are taking a shower and your water temperature is dipping down from 100, a nice cozy 107 down to like 100 or less, we can actually top you up without trying to heat the entire tank. And so what that allows us to do is, sure, we're using electric resistance, which is less efficient, but we make sure you get your hot shower, you get your joy, but you still get your savings, right? And so our goal, Like we kind of tagline on our website. It's like save power, saver showers. It's like our goal is you never run out of hot water, but you still save a bunch of energy and money, and so you don't notice it, right? And so some days you're going to be less efficient than others, but that's okay as long as on average you're very efficient.
I like that. Save powers, saver showers.
Save power, saver showers. Yeah,
Nice.
yeah,
And then just to say it, the virtual capacity is this is where you're heating, if instead of just heating the water up to 120 degrees or whatever a normal tank is, you can get it up to what, 160 or some higher temperature, and then mix it with water, mix it with cold water, so you have effectively a lot more hot water you can deploy at the desired temperature.
yeah. There's two sides to it. So you heat the tank to a high temperature, like 150 to 160 degrees. Then the second piece is then you still use that booster heater I was talking about. Just to, I mean, when we have it in party mode. So one of the things we actually found was a lot of people, particularly in heat pump water heaters, they were recommending way oversized heat pump water heaters. Like, so for this happened to me, um, not that big of a family gets recommended an 80-gallon heat pump water heater because they're worried about Thanksgiving. They're worried about when like the in-laws
Right.
visit. They're not worried about the
For the
average
worst
day.
case scenario, yeah.
Yeah. And so then what you end up having is you have this big tank that takes up a lot of space, but then you have standby losses. So then you have this tank that is kind of like sitting more, and so you have more standby losses. We took a different approach. We said, like, let's get a lot more out of the tank sometimes. And so we superheat the tank. We call it party mode, because not every day should be a party, but it's okay to have a party once in a while. And and so like I did this when, over Thanksgiving. I also have this very embarrassing story of my kids both came home with lice, and I can't tell you how many like times we had to take showers and baths, and there's all these preemptive baths and everything. And Reservoir kept up. It was not our most efficient day. I'll be honest about that, but it was able to keep up. I didn't need an 80-gallon tank sitting there the rest of the year, right? And so that's how we do it. There's one other nuance to this, because there's so if you have a tank of water and you have water sitting in a steel tank, it's going to corrode the tank, right? And you have what's called in a typical water heater, you have what's called a sacrificial anode rod. So the water eats the anode rod instead of the rest of the tank. And that's to protect it. Once the sacrificial anode rod is gone, it'll eat the tank. If you're actually elevating the temperature of the tank, so instead of 120, you're elevating it to 150, you can actually accelerate corrosion 6 to 7 times. And so you end up like destroying the tank faster. We actually have a totally different corrosion protection system as well. And it's electronic corrosion protection. And so we can actually vary that based on your temperature of your tank, even if it goes lower, and there's some benefits to that as well. But that's one of the ways we can, now we're starting to get into like the idea of like a thermal batteries. You can effectively store more heat in it. But we actually effectively can get more cycles out of our battery because of that electric corrosion protection, right? So.
On the point of it being like a battery, how much, when I think about how much kind of energy savings or money savings or emission savings this can impact, how much of that is about load shifting versus just the efficiencies of heat pumps and this kind of thing?
Yeah, I guess I think about that as like two different kind of phases of the company. Like the first one, it's about energy efficiency, and you get gigantic efficiency savings, right? If you're switching from like an oil water heater in the Northeast, you can be saving like a ton of CO2 a year, that kind of thing. Um, so that's like the biggest impact at like the home level, and especially if you have solar panels, you can effectively heat your water with solar panels. We have a thing called solar sync, where it can sync with the sun, so that you're using the clean energy from your roof to do that. So then you can even be more confident that your electricity is clean. I think when you start talking about the grid, it's a bit more complicated. So that's when you start talking about like, are there a bunch more of these? Once you start getting into the install base of thousands of these, if you can have them, these being reservoirs, if you can have them work in concert, you can shift when energy is being consumed, which means you effectively create more capacity on the grid. if you effectively create more capacity on the grid, it's like the basic idea is it's kind of like a highway. Um, you know, most of the day there's plenty of lanes on the highway, except at rush hour. And so one option you have is build more lanes, which is expensive, or if you could figure out how to move that traffic to a different time of day. It's actually more straightforward on the electric grid because you can have storage, and a tank of water is storage. And so you don't care when we heat your water. We can heat your water at 3 in the morning. You care when you get your shower, right? And so if you shift when that energy is used, you don't need to build as much infrastructure. And so that's one big piece. So that's a big climate impact in and of itself. You don't build new big
Like peaker
peaker
plants
plants.
and
Yeah, exactly, stuff like that. Like some of the dirtiest energy you can throw on the grid.
Mhm.
On the other side of things, you can deal with you can actually treat it as storage. So when the sun's shining in a place like California, where there's sometimes too much solar energy, instead of curtailing that, instead of just like turning it off and doing nothing with it, you can heat water then, and shift it to then. So what that ends up doing is it allows you to sync with more intermittent energy sources. And so that's why I say it's a lot more complex. Like actually, the mission for us as a company is one to make homes more affordable, comfortable, and healthier, but then to balance a clean grid at the same time. And so once you start getting to that, I guess to put it in perspective, if we had every water heater in the Boston Metro, like the MSA, as an intelligent grid connected water heater, you would have almost as much capacity that you could shift around as a nuclear scale power plant, without building a nuclear scale power plant, right? And so there's so many next order effects to having intelligent appliances that have like built-in storage, and like a water heater is honestly like the holy grail of this kind of stuff, because it a tank of water is, with intelligence, it's effectively a battery because you're storing heat inside it.
Right, right. And it feels a lot more feasible to get a lot of those installed in homes around the country than like a bunch of power walls or something like that. Like people need water heating anyway.
Yeah.
Um,
I'll tell you
yeah,
what, hot water is required by law.
yeah,
Nobody's going to go without it. Um,
right.
and so yeah, I mean, you're not going to eliminate the need for power walls,
Mm,
because you still have lights, you still have computers, you have, other things like
mhm,
that. But like, if you actually think about it, the large majority of home energy is actually thermal. It's heat.
mm,
So it's like from three things: it's heating your water, it's heating the space, or cooling the space. That's like 70% of home energy. And so if you were able to store that in tanks of water, um, that's a lot more cost effective than lithium ion. Like it doesn't make any sense to go from like solar energy to electrical energy to chemical energy back to electrical
back,
energy then to
yeah.
heat.
Then the
Because if you could
thermal,
just
yeah,
store it as heat, then you have what you need, right?
yeah, yeah, yeah. I chatted with Jane from Harvest Thermal, who is doing
Mm.
kind of that and then deploying it as heat for heating your home, if I
Yeah.
remember right. Yeah.
Yeah, and you can do it with cooling as well. So there's
Mm,
companies like, they were bought by Train, but there's companies like CalMac that has big tanks of water tied to heat pumps, and they're actually cooling it down, and then using heat exchangers for air conditioning. Harvard actually has this facility in Alston where they have like a 1.3 million gallon tank of water that they cool down, and they pump cold water all over the place, use a heat exchanger, and so you can store energy that way. Where that's actually interesting. I mean, I already told you why it's interesting for the grid. Like, so the utility company might be able to avoid infrastructure, and it actually to a very granular level, which is what we can talk about. But what we really want to do is give homeowners more control. And so, as opposed to going through like a big like permitting cycle of trying to work with utilities and whatnot, we have what's called time of use rate sync. So if you have off peak energy rates, you as a homeowner can already use Reservoir as a thermal battery. Like you don't need to get permission. You just shift when you do it. And participation rates are way higher with these kinds of programs if it's automatic. But you can also do it with your solar panels. One, if you just want to make sure you're using your solar energy, but in some jurisdictions, you actually have incentive to consume it on site. Like, when you
mm-hmm.
export it back to the grid, it's for less of the value than
Yeah, you
what
get,
you pay for your there.
yeah. In my area now, it's like pennies on the dollar.
Yeah, yeah. So it you can already, so in that sense, Reservoir is a tool to actually save you even more money. And so it starts stacking like that way, right?
Yeah. I'm curious about your process because you've added kind of a lot of really compelling features for the user. You've invested in industrial design, or at least from the outside, it looks like you've really paid careful attention to the industrial design, the user experience, all these features. I also know this stuff adds cost and additional heating elements and all of this. I'm curious about how if you can say anything about your process for how you understood which were the right things to tackle, what problems you were solving, or what feature benefits you wanted to bring to users, and how you made the decision about that sort of cost benefit trade off when defining the product.
Yeah, absolutely. If you add more, it adds more cost. You can also drive down costs in different ways. There's how you manage your supply chain, how you manage your assembly, how you manage your install, and different things like this. And then also costs on the back end in terms of like the robustness of your components. And so I'd just say, like, as a company, some of our superpowers have to do with supply chain. And so we're actually able to add a bunch of features without actually adding a ton of cost. And some of that is, the computer allows you to do so much more, right? Like we're able to take hardware and get a lot more out of it because of the computer. This is actually something we did at Form Labs as well. Like we were able to bring the cost down while actually raising performance. And that's because it's this beautiful marriage of software and hardware. And so you can get a lot more out of it that way. You still don't want to just throw random stuff on it, right? And so, we can talk about like how you built a startup, how you built a company, and stuff like that. But like one of the things is you definitely need to talk to customers, but you need to get in front of customers, in our case, homeowners, faster and faster. Because I think like there's one thing that someone might tell you, like, I don't care about that. I do care about that. This doesn't matter to me. And then there's another thing when you actually put it in someone's house as fast as possible. Obviously, being responsible. But so the way we were able to streamline a lot of different things was talking to customers, seeing what actually matters. And honestly, we started the company initially thinking like, okay, we need to make sure there's plenty of hot water and we need to save energy. And those are like the two sides of things. What we ended up finding out was there was a lot of heads nodding and a lot of excitement about the water damage prevention features. And like a way I put it is like, a homeowner is most terrified of fire, but probably worries the most about water, right? Like, and then if you're an owner operator of like a bunch of apartments and everything, water heaters are terrifying, right? Like, like you have a leak that you did not predict, and it's all over everywhere, and it does not stop. It damages multiple apartments, and so like a quarter of home insurance claims are water damage, and so that's where we started really leaning into the home protection features. We're like, this is something that people really love. Um, and they're paying for different devices. Like people do pay for leak sensors, they pay for recirculation pumps and different things like that. We realized we can actually save you a bunch of money by bundling them together. We can actually raise reliability as well by assembling them in the factory as opposed to, bespoke on site. So,
and when you say you got things into homes, or you got in front of customers in their homes quickly, does this mean you are bringing early prototypes, installing them in customer homes and doing testing, or what did that look like?
Oh no! So we have fully certified products. We have ramped manufacturing. We're in
right.
Yeah. So
You're currently installed. I was more
yeah.
curious about the kind of development process, and as you were sort of
Okay.
navigating, understanding customer needs and stuff like this. Were you?
Oh yeah, we were getting prototypes in customers' homes. I put one in my own home. And I annoyed the hell out of my engineering team. Um, so to be honest, like just asking like different questions, and I think like that's a real thing. Like so I'm the CEO of the company, and I think one of my chief jobs like is to think like a product manager, think like the customer and everything. And so that's there's the term dog fooding, right? Like, and you'd say like, I think instant hot water would be great. Well, let's get it in our house. My wife loves it. She gets really mad. She got really mad when it wasn't working, like the early prototypes and stuff like that. And so you also learn when you're biting off more than you can chew. So,
Mm-hmm. Mm-hmm. But yeah, say more about where you are in the process. So I think I read an article saying you have units installed in the Boston area with real customers already. Kind of where are you in this sort of commercial ramp process?
Yes, we're rolling out. We've been reasonably quiet to date. We've been focused on the Boston Metro. We've got line of sight to being in hundreds of homes, but we absolutely want to be national. But we're doing. I guess this is the kind of thing with hardware. There's like we want to go fast, so we learn fast, but we want to do it in a responsible way, and that's why we're starting out regionally. So we're in the Boston Metro. We just recently expanded to New Hampshire and Maine. Then we'll be expanding to our first like true new metros soon. Yeah.
Nice. And um, the business model, you're selling hardware direct to customers? Is there any kind of service model or anything like that? What's the business model?
Yeah. Yeah. Well, so I have a strong belief that when you're bringing a new technology to market, you should first bring it to market yourself. I think there's nobody else that's going to back it up in the same way. But like representing it as well as like when something goes wrong, because I mean, there's not a hardware company in the world where something doesn't go wrong. And so what we're doing first is we have our own licensed plumbing company. It's purely to install water heaters, purely to install reservoir, and we have amazing reviews and we have all these kinds of things. We have already started announcing partnerships with like heat pump installers. We'll be seeking out as well as incentive um, inspectors as well, home performance inspectors. We will be expanding to solar installers and others to work with us. We still do the install. But then as we really get going, we absolutely will be adding trusted install partners. The number that I think about all the time is 120 million homes. And there's no way we're going to get to 120 million homes without some amazing partners. But we're starting doing it ourselves. But that gets back into that like product side of things, right? Like the dog fooding side of things. Like we understand our product, we understand our process, we understand our limitations. We understand our customers better than anybody. So.
Uh-huh. Uh-huh. And 120 million homes. Is there a way you scale? Clearly, on the install side, having partners to support the scale of installs. On the kind of sales side, is there a way you scale to, I don't know, through developers or apartment buildings or something like this that helps with that scale, or is it always kind of a direct to consumer thing?
Well, there's the D2C, direct to consumer. Then there's the B2B to C, business to business to consumer, which is like working with heat pump installers, working with solar installers. And so we'll be doing more of that. But then there's the other side of things, which is we've been talking about utilities to a certain degree. And utility partners are a broadcast potential where there's value for them, value for the homeowners, insurance companies as well. So we're excited about demonstrating the water damage prevention of reservoir because it's valuable to insurance companies and to the homeowner themselves. But we're also in active conversations with multiple developers and operators. And we're a new company, so we need to earn their trust. And so some of that's like getting in more homes, demonstrating it to them. But yeah, we want to get to every home in America.
And can you say something about the cost and how a homeowner should be looking at it as far as kind of upfront costs and savings over time?
Yeah. So we have been we've been advertising something very, very different. So like typically when you think about getting a water heater installed, you can see the hardware costs, and then you got to go pay a plumber to install it. And it depends. Like in the Boston Metro, you're required by code to have a plumber install it. And so then it's a lot more opaque what it actually costs. So to date, we've been charging $5,500 fully installed for the product. So that includes the hardware as well as the installation. So it's actually cheaper than a tankless gas water heater that is directly competitive in the Boston Metro with heat pump water heaters fully installed, even if you buy them at Home Depot. And then it's within striking distance of generic old water heaters. What we're actually excited about doing is we're about to we've been doing pretty well on the cost side of things. We are going to be charging less than $4,000, including incentives, to get started with Reservoir. And then we'll have some financing options as well. So you'll be able to get started with Reservoir for very low cost, and then actually save money just on the fuel cost. So, if you have like an electric resistance water heater in Boston, you are spending between $1,000 and $1,500 a year in water heating. In California, if it's electric resistance, it's going to be even higher. It's going to vary across the country. If you switch to a reservoir in one of these metros, we can save on the order of $800 to $1,000 a year, right? Like that's a ticket to Hawaii. You can have some fun with your family and things like that. And so when we combine that with constantly aiming to be the most affordable but most comfortable option without compromise, I think we're going to see just like some really, really awesome adoption of this, because it should be a no-brainer. Like any of my friends that have an oil water heater, any of my friends who have an electric resistance water heater, I'm like, can do you a favor. It can save you a bunch of money. And now we're about to make it a lot easier to get.
Yeah. And would you recommend people replace functional water heaters with perfectly fine functional water heaters with this, or is this something people should be thinking about as their current water heaters reach end of life, which is typically about 10 years or something like that?
Yeah. I would say if your water heater is more than 7 years old, you should take a look at it, and you should think about it. Unfortunately, most people check it and then wait until it fails, and then it's like it goes from the thing you don't think about to being the most important thing in your life, and that's where you probably get what you don't want or pay more than you want. Um, then it's going to depend, right? Like, so if you have an electric resistance water heater, it actually makes sense to swap it out from a cost perspective. Like in the Boston Metro, like the payback period is great. If you have an oil water heater, it's great.
Oh, the other thing, you've mentioned cost a couple times, and it sounds like you've been able to reduce the cost pretty significantly again. Can you say anything more about that? It sounds like a lot of that is your kind of supply chain expertise on the team. What exactly is happening to get you to a lower cost?
It's supply chain expertise. It's how you integrate components. So, like it's going to cost you a lot more to install a recirculation pump in the field than it will when it's already integrated. And that's I'm not going to tell you the exact costs. But then it's also just an efficient team, like on the installation part. Like what most people don't realize is the install usually ends up being the most expensive part of the system. And I guess this gets to like a core belief of ours. I said, like, better products get adopted, more affordable products get adopted, and I there's a lot of conversations around the green premium and all these kinds of things. Like, I don't believe in the green premium at all. Like once you're talking mass market, like the green premium definitely exists for a subset of humans. um, but our goal is absolutely to just be a no-brainer regardless of that. And then you happen to save the environment, save the planet, all that kind of stuff. And so this is just something I learned at Form Labs. This is something that my co-founder Gabe learned at Apple, as well as at his last company, Nebbia. And then Jake, who he learned this in like so many different places where that guy's done so many hardware startups. There's expensive ways to do hardware, and there's less expensive ways to do hardware, and then there's less expensive, high reliability ways of doing hardware, and we're choosing that one.
Yeah. As you think about the future of Reservoir, what is your vision for the company? What kind of impact do you hope to have? We got into this a little bit. I thought it was interesting talking about how as the installed base scales, how that can kind of have a grid scale impact. Can you say more about where you hope the company to go?
Yeah. Well, so I mean, like, so water heating is a start. If you think about hot water, it's kind of at the center, or it's one of the things that's at the center of energy. It's at the center of water, obviously, but it's also at the center of health, right? Like you're touching your water, and I think those are like three things that we think a lot about as a company, and we're constantly asking ourselves, how can we give homeowners more control over their energy, their water, and their health, but also their finances. And so ultimately, what we really do want to do is, one, we want to be in every home in America. But we also want to manage all the energy and all the water in those homes so that homeowners can afford to live more comfortable, healthy lives. And so, there's a couple aspects of that. Like one, there's getting into more and more appliances like home heat. We've talked about cooling as well. Like, of course, that's further in the future. But then there's the grid side of things. I think we one of the ways you actually, as a homeowner, can be more empowered to save the planet is if the grid itself is cleaner. And we think that, using our kind of technology as a thermal battery enables a cleaner grid. So does that answer your question?
Yeah, totally. Yeah.
Okay.
All right. I want to wrap us up and watching the time. Is there anything? I have 3 questions that I ask everybody at the end of each episode, and I'm ready to go to those unless there's anything you want to hit that we haven't talked about yet.
I think that's for the most part it, unless you're not going to ask me where can people find out more.
Oh yeah, I should. I will ask you that at the end. Yeah.
Okay. Good.
Okay. Okay. I have 3 final questions for you. The first is, how optimistic or pessimistic are you about the future of the planet and why?
I'm very optimistic about the future of the planet. I don't think the path is going to be easy or simple, but I am absolutely a techno optimist. We've just constantly proved throughout human history that technology enables us to get more with less. There's been so many different predictions of overpopulation and the Earth collapse, like the population collapsing by the 70s, and it didn't happen, and these kinds of things. And absolutely believe that we have so much cool technology right now, like the rate at which solar energy is being deployed, the rate at which batteries are being deployed, all this kind of stuff. I think it's there. Fossil fuels are also more expensive right now for reasons we don't need to go into, but it's an effective carbon tax, right? And so it's incentivizing electric, it's incentivizing solar, all that kind of stuff. So I'm optimistic.
Who is another company or individual doing something to address climate change that's inspiring you?
I mean, I take so much inspiration from the electric vehicle market. I'm not going to go into one that's a little bit more politically polarized right now, but I think the different electric vehicle manufacturers, honestly, I think it's amazing, like how they're demonstrating how the electrical tech stack can just be so amazing, and it can also be better for the environment. And so I think it's just like so clear, like you can have the sustainable thing that is also the better product, and that's where I take inspiration from. Yeah.
Yep. Seems like you're following that approach, which makes a lot of sense. What advice do you have for someone not working in climate today who wants to do something to help?
Well, if you're in Boston, we are hiring people, so let me know. I think if you're not working in climate and you don't want to transition to working in climate, I think start at your house. There's just more amazing things within your grasp that you can already do, like the availability of solar panels that you don't need installed by someone else. The fact that you can replace your water heater in a morning or an afternoon and dramatically change your comfort, your finances, your energy, and carbon footprint. You should start with those kinds of things. Get a home energy assessment, those kinds of things. Drive an electric car.
Yeah. Cool. Last thing, how can people find out more? Where should people go?
Yeah, go to reservoirhome.com. You can find out a lot more about us, our product, and lots of other things there.
Awesome. Luke, that was really fun. Learned a lot. I'm excited for Reservoir to make it out to my area. I'll be watching.
Sooner than you think.
Thanks for everything you're doing, and thanks for your time.
Yeah, thank you, Dylan.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.